Today we're going to talk about factoring and solving quadratics to help us solve polynomial equations. So recall that when you're solving equations, you can use one of the three methods. For quadratics, you can factor, set the equation equal to 0 first when you do that. If you can't factor, remember you could look to try to take the square roots when there's no linear term, or you could use the quadratic formula. So just recall the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So these are different methods that you can use. So looking at the first one, the first thing that I'm going to do is set this equal to 0 because I can see I have a quadratic, a linear, and a constant term. And I'm going to write the terms on this side. So I'm going to add the 12x and subtract the 38 because I don't like working with a negative quadratic term if I don't have to. So when I do that, I get 12t squared minus 38t plus 16 equals 0. Again, all I did was take these two terms and put it on the left side. Now that I have that, the first method that we can use is factoring. So I would notice right away that I have a greatest common factor of 2. So you're going to take out the 2 first. That gives you 6t squared minus 19t plus 8. And then for the next part, you can see if you can factor the trinomial. So this would be a number in front here, so you'd have to do the Swedish fish factoring, or you can do factor by grouping that you've learned last year. So for this, I'm going to do the Swedish fish factoring. So I'm going to take this and put it over here. So Swedish fish don't really swim. So the 6 gets multiplied by the 8. That's the slide. So just bring down this 2 has to come down. So that becomes t squared minus 19t plus 48 equals 0. And then we look for factors of 48 that add up to negative 19. Again, hopefully you know your factors, but if not, you could always use your calculator to help. So factors of 48 that add up to 18. So we're going to divide this by x. And when you look at your factors, right away can see that I have 3 and 16. So 16 plus 3 gives us 18. So those are going to be our two factors. So we have 2 times t, and for this, since this is plus and this is minus, both the middle terms are minus, so minus 16 and t minus 3, because 16 negative times negative 3 is positive 48. Negative 16 plus negative 3 is negative 19. And then remember, if you move that first term, you have to divide it back out. That's what the d stands for, so divide by 6. So we get 2 times t minus, and then r stands for reduce. So 16 over 6 reduces into 8 thirds, because we're dividing both terms by 2. And then this becomes t minus, and this reduces into 1/2. And then, of course, that swing, if you have any fractions left over that didn't reduce with a 1 in the denominator, you swing those numbers to the front. So that becomes 2 times 3t minus 8 times 2t minus 1. And of course, when you get better at factoring, you should be able to do this factoring without having to do all those steps. So the next part we want to do, of course, we're trying to solve. So the first thing we're going to do is set each factor equal to 0 and solve. For the first one, we have that 2 in front, and remember that 2 does not equal 0, so that's not going to be a solution of our equation. So 3t minus 8 equals 0, and 2t minus 1 equals 0. Both those has variables, so we do want to solve those. So when I solve this, add the 8 divided by 3, so I get t equals 8 thirds. And over here, add the 1, divide by 2, and t equals 1/2. And so these would be my solutions. Looking at the next one that we have, so again, this is a quadratic equation. And for this quadratic equation, I would notice that because it's a binomial squared, probably the easiest way to solve this would be to use square roots. So the first thing I would do is get this portion by itself using PEMDAS backwards. So we want to get rid of anything add or subtracted to the exponential portion, and then multiplied or divided. We don't have anything add or subtracted on the outside, so we're going to just divide by 3. So when I do that, I get p plus 1 quantity squared is equal to 27. Now I can get rid of that exponent by taking the square root of both sides. Remember, when you take the square root, don't forget that plus or minus that goes in front. So then I get p plus 1 is equal to plus or minus the square root of 27, which we can reduce. So anytime you have a square root and it doesn't give you a perfect square, make sure that you reduce your radicals when possible. So this is 9 times 3, and the square root of 9 we know is 3 times 3. So that 3 goes on the outside. So this is actually 3 square root of 3 is what it reduces into. And then the next step was to solve for p, so we can subtract the 1. So p is equal to negative 1 plus or minus 3 root 3 would be the answer here, because you always want to find the exact solution when possible. So that means you could write it as p equals negative 1 plus 3 root 3, and p equals negative 1 minus 3 root 3. So you could write it like that too. If you didn't want to write the negative 1 in front, you don't have to. Another way you could write this is p equals plus or minus 3 root 3 and then minus 1. Just make sure that doesn't look like then minus 1 is underneath the radical here. That's why I normally write it in front. So any one of those ways would be fine to write. So that one was using the square roots. Looking at the next one, for this one, it's already set equal to 0. I have a quadratic, a linear, and a constant term. So do I have factors of 10 that add up to 8? So I know 1 and 10 doesn't work, and 2 and 5 do not work either. So that means I have to use the quadratic formula. So for this one, recall that a is equal to 1 because that's what's in front of your quadratic term. B is equal to negative 8. And c is equal to 10. So I'm going to plug that in. So, and actually we're not using x, we're using z for a variable. So z is equal to, we get negative b, so negative 8 plus or minus the square root of b squared, because you're squaring that negative, so make sure that you put it in parentheses, minus 4 times a times c, all divided by 2 times a. So z is equal to negative 8 becomes positive 8, plus or minus the square root of negative 8 squared is 64, minus 4 times 1 times 10 is minus 40, all divided by 2. And then the next step would be z is equal to 8 plus or minus the square root of 64 minus 40. It gives us 24 over 2. 24 is not a perfect square, so I can go ahead and do my work off to the side here. The square root of 24, when I break that down, that's you could do it a couple different ways. I'm going to go ahead and do 2 times 12, and if I break down 12, that gives me 3 times 4, and 4 breaks down into 2 times 2. So the only group of 2 that I have is the 2 here. These do not make a group of 2, so those stay multiplied underneath. So this is actually equal to 2 times the square root of 2 times 3, which is 6. So that's what I'm going to use. So we get z is equal to 8 plus or minus 2 root 6 divided by 2. And of course, we're not done because the 8 is getting divided by 2 and this 2 root 6 is getting divided by 2, so we can simplify. So z is equal to 4 plus or minus root 6. And that gives me my 2 solutions. So again, we did the factoring, we did taking square roots, and then we did using the quadratic formula. So find all the solutions is the next thing we're looking at. So the degree is going to give us the number of solutions for a polynomial equation. So these quadratic equations, notice the degree is 2, so that means you're going to have two solutions, whether or not they're real or imaginary. So looking at this part, we have for 12, we're going to find all the solutions of each of these equations. And so we're going to use the degree to help us. So looking at this first one, the degree of this, because it's in standard form, we know is 5. So that means there are 5 solutions. So I'm going to use my factoring quadratic formula, whatever I know to help me solve this. First thing you do is always look for the greatest common factor. So the GCF of this, I can see all of these are even numbers. So I could start with 2. I can see that 4 goes into all of these. So 4. I can see of x to the 5th, x to the 3rd, and x. So I know x goes into them. So that means I want to take out that 4x. So I'm dividing it out of each of these terms. When I divide it out, I get x to the 4th minus 10x squared plus 9. And then here I have 3 terms. And notice that this middle term is half of this term here. When that happens, you can see if you can factor this. Some students might try to use the quadratic formula. However, you cannot use the quadratic formula here. Why not? Because this is not a quadratic equation. It's x to the 4th. And so remember that means this is a quartic right here. The actual entire equation in standard form we know is quintic. But this portion right here, you cannot use quadratic formula because, again, it's not quadratic. So I can go ahead and try to see if I can factor this. So I'm going to set up my parentheses sets. So instead of this being x and this being x, we need it to be x squared and x squared, because that times that gives us x to the 4th. That's going to help us out with our middle term. So factors of 9 that add up to negative 10 would be minus 9 and minus 1. And of course, if you look here, this is something that is a binomial with 2 terms, and the 2 terms you can take the square root of each of them. So this is the difference of 2 squares. That factors further. So 4x times this becomes x plus 3 times x minus 3. Same thing here, you can take the square root of both these terms. So again, the difference of 2 squares. So x minus 1 times, or I'll do plus 1 and x minus 1. It doesn't matter what order you write it in. And now I can go ahead and solve. So this has an x on the outside, so we do want to set that equal to 0. And then here you only need to write it once, so x plus 3 equals 0, and same thing here, x plus 1 equals 0. So 0 divided by 4 gives us x equals 0. Subtract the 3, we get x equals negative 3. Subtract the 1, x equals negative 1. And those would be our solutions to our equation. So then why didn't I not get 5 solutions when I am looking at this right here? Well, remember we have multiplicities. So here, negative 3 is a multiplicity of 2, and oh, let's go back. Sorry, for some reason I was thinking this was x plus 3 and x plus 3. Same thing here. My bad. So we do have 5 solutions if I thought those were multiplicities. Sorry about that. So let's try this again. 4x equals 0, x plus 3 equals 0, x minus 3 equals 0, x plus 1 equals 0, and x minus 1 equals 0. Divide this by 4, we get x equals 0, x equals negative 3, x equals positive 3, x equals negative 1, and x equals 1. Sorry about that. So now you can see we do have our 5 solutions. If in fact this was instead a plus 3 and a plus 1 like I was making it out to be, then those would have just been multiplicities, which account for solutions. So that means we have our 5 solutions. If we were to think about doing what we did the other day, we could think about graphing this. If I think about graphing this on my graph, I would have 0 of 0, negative 3, positive 3, negative 1, and positive 1. And then this is degree 5, so this is odd, and the leading coefficient is positive, so that means if it's odd positive, the left end goes down, right end goes up, so this is up, this is down, and these are all multiples these of 1, so they're all going to cross through. So this crosses through, cross through, cross, and cross. And I didn't need, oops, I'm missing a 0. It's because that should cross. So cross here, sorry, at 1, and then cross here. So I didn't need to find the y-intercept because it was at 0, 0. But again, I knew I graphed it wrong because I accidentally made my graph go here, and I'm like, well, these are all multiplicities of 1, which means they cross through because they're odd, and we know that if it's even multiplicity, it would bounce, and that gives me my graph. Let's go ahead and look at the next one. So for the next one, same thing. First thing I would do is set this equal to 0 to put it in standard form, so 2x to the 5th, and then I'm going to add the 10x cubed to the left side minus 72x. And so then we're going to go ahead and do the same thing. First thing I would do is look for a greatest common factor. So the greatest common factor looks like it's 2x, and then that means this would be x to the 4th plus 5x squared minus 36 equals 0. Again, right here, I can't use the quadratic formula, but I can look to factor because this middle term is half of this term here because it's squared in the 4th. So do I have factors of 36 that add up to 5? Yes, I do. 9 and 4. So 2x, this becomes x squared and x squared. So again, our middle term is positive with the larger term, and then one of them has to be negative with the smaller term. So positive 9 and minus 4. These right here, the x squared minus 4 factors further. This one does not because we don't have the sum of squares, remember. We only have the difference of two squares. So this becomes 2x times x squared plus 9 times x plus 2 times x minus 2 equals 0. So this then is the factored form. We can go ahead and set each factor equal to 0 and solve. And so here we get x equals 0. Here x squared equals negative 9. How do I get rid of square root? Take the squares side. Remember we said before, if this square was right here, we didn't have to write it. But notice that we're not squaring both the x and the 9. We're just squaring what's on the inside. So you do need to keep that square there. So then now I can take the square root. So, and don't forget your plus or minus. So plus or minus the square root of negative 9. And then remember, if you have a negative underneath a radical, what happens? That means you have imaginary solutions. So that becomes x equals plus or minus I times the square root of 9. And what's the square root of 9? 3. So x equals plus or minus 3I. When you have imaginary solutions, remember that means that you're not actually touching the x-axis. So this won't show up on your graph, but they are solutions regardless. So then x here is negative 2 and x equals 2. So we should have 5 total solutions. So this is 1, 2, 3, 4, 5. So that gives me all my solutions. So then x would be equal to 0 plus or minus 2 because we have positive and negative, and plus or minus 3i. So if you're curious as to what that would look like on the graph, if I were to think about graphing this, so we have on my graph 0 and then plus or minus 2, so there's 2 and negative 2, and we don't actually graph this because it's imaginary. And for this, it's again degree 5, which is odd, and the leading coefficient's positive, so left end's down, right end's up. And for this, these are odd multiplicities, so they're going to cross through. So cross, cross, and cross. So this is similar to what your graph would look like even though we have these imaginary solutions. Remember, think about quadratic equation. If your quadratic equation has imaginary solutions, remember then that means it either opens above the x-axis or below the x-axis, but it doesn't cross through. That's something that we looked at in Math 2. Looking at question number 14, same thing. Let's go ahead and set this equal to 0. So I'm going to add this to the left side because I don't like working with the largest term being negative if I don't have to. So 6x to the fourth minus 27x cubed plus 15x squared equals 0. Go ahead and see if you can do this one on your own. When you're done, you can unpause the video. So for this one, I have a greatest common factor is the first thing to look for, which looks like 3 can go on to all of these and 2 x's. So when I take out 3x squared, I get 2x squared minus 9x and then plus 5. And for this, now notice that this term right here is quadratic. So if you wanted to, you can use the quadratic formula. You can try to factor 2 if you want. So if I take the 2 times the 5, I would get 10. So do I have factors of 10 that add up to -9? Well, think about your signs here. So 3x squared. If I try to factor that, this would give me x and x. So because this is negative and this is positive, that means that we would have to have a negative and a negative. So the factors of, when I take this and multiply it, factors of 10 would be 10 and 1 to give this 9. But the problem is, since both these are negative, that's not going to give us a negative term. So that means this does not factor. So since that does not factor, we're going to have to use the quadratic formula, and we're allowed to use the quadratic formula on this one because unlike the other ones, this was to the fourth and this is x squared, so that means we can. It's quadratic. So the 3x to the squared we set equal to 0, and 2x squared minus 9x plus 5 equals 0. So here when you solve, you get x squared equals 0, so x is equal to 0. And here we're going to use the quadratic formula to find our solution. So a is equal to 1, b equals -9, and c equals 5. So x is equal to -9 plus or minus the square root of -9 squared minus 4 times 1 times 5 all over 2 times 1. And then we're just going to go ahead and simplify. So x equals, this becomes 9 plus or minus the square root of 81 minus 4 times 1 times 5, so minus 20, all over 2 times 1, which is 2. So we get 9 plus or minus the square root of 61. Sorry about that. I wrote my A as 1, and the A is not 1. It's 2, so that should have been a 2 there. And that would be a 2 and 2. So that means this is 4. And this would give me 40 minus 40 because 4 times 2 times 5, so 8 times 5 is 40. So this is 41 over 4. And then the square root of 41 does not simplify, so that means we can't divide out the 4 from either of these terms. So that means our solutions are 9 plus or minus root 41 over 4, and x equals 0. 0 was squared, so this is a multiplicity of 2. And so if we go back up here, what was the degree when we're in standard form? Notice the degree is equal to 4, so there were 4 solutions. So this counts as 2, so that's 2, and the plus or minus makes this 2. So that's the 4 solutions. All right, so the last problem we're going to look at is number 15. For this problem, the reason that we learn how to factor these polynomials is because in order to graph this, we need to factor the x cubed minus 2x squared minus 3x. So first you look for your GCF, which is x. So once you take that out, you get x squared minus 2x minus 3. And then, of course, you can go ahead and factor that further. So that factors into x plus 1 times x minus 3. And then if you're setting each factor equal to 0 to find the x-intercepts. So here we get -1, and here we get 3. So x equals 0, x equals -1, and x equals 3. All of them are to the first power, so multiplicity of 1, which means they all cross. The degree of this is degree 3. So the leading term is x cubed. Remember, there's 1 in front, so that means that this is odd, and the leading coefficient's positive. So odd positive, remember, means that the left end goes down and right end goes up. So negative infinity goes towards negative infinity, and positive infinity goes towards positive infinity. Remember, to find the y-intercept, you plug 0 in for x, so we get 0 cubed minus 2 times 0 squared minus 3 times 0. So the y-intercept, of course, would be 0, 0. And then go ahead and graph. So on my x-axis, I'm going to go ahead and just count by ones. And so we have 0, -1, and 3. And my end behavior means that this end goes up, this end's going down, and for each of them we are crossing through. So this crosses through and this crosses through. So this is just a sketch of what your graph would look like. And that's it.